Welcome to Unofficial ACI Guide. I'm Jody. Today we're going to look at MultiPod and what that looks like for ACI. We're going to look at design considerations, features you should have enabled, and caveats that you should be aware of. Let's take a look.
All right, good morning everybody, and we're back and we're going to talk about MultiPod connectivity today. So all of the different video snippets that you've seen so far have shown traffic going from one pod to another. We may have referenced the pods, but MultiPod, what this is doing for us, it's an architecture that allows you to have two different locations of ACI actually functioning as one fabric. You've got one cluster of APICs which controls the configuration and the commands that are sent to the switches from that one cluster. Now, even though we have one cluster, we do have two spines at one location in pod 1, and then one active APIC in pod 2 with a standby APIC in pod 2 as well. In the event that there was an issue, we can bring up that secondary pod or that secondary APIC. MultiPod, the advantages of MultiPod is from a configuration and operations perspective, everything does look like one APIC or one ACI fabric. The ISIS and the BGP routing, those routing updates are constrained to each individual pod. So a routing incident in pod 1 will not impact something in pod 2. Something you need to be aware of, and not necessarily a con, but definitely something you need to be aware of, is we do have one APIC cluster. So if the entire APIC cluster were to experience an issue, then you would affect both pods, or at least the ability to see and configure those. So that's where multi-site potentially gives us some benefits of having two separate APIC clusters, two completely separate configuration and control fault domains, right? But we're using MultiPod today. Javid is going to take us through and deep dive what the multicast setup looks like for MultiPod, because with MultiPod, there are several requirements that you have on the yellow box up here, which is where you see Baboon, Cougar, Coyote, Llama, those 4 IPN devices. You've got to have Jumbo MTU. You've got to have DHCP relay configured. You've got to have PIM bidirectional configured and supported. So the devices that you're putting in the IPN, there are requirements for those devices, and we'll talk through all of those, as well as show some best practices, some things to be aware of. We'll display host routing, so it's going to be a good time. So Javid, at this point, why don't you take us through kind of the setup that we have, what is going on, and then kind of dive into the multicast requirements and how we troubleshoot some of that.
All right. Good morning. Thank you, Jody. I'm sorry. So we're going to talk about MultiPod today, and we're going to go look at the configuration, and I'll show you how we configure these boxes and how you set up the multicast binder. So we have 4 boxes here: Baboon, Cougar, Coyote, and Llama. Baboon is the primary rendezvous point for multicast, and Cougar is the secondary. So let me show you from the configuration let me telnet to one of these boxes. Go to Baboon and show you the config. Show run. Let me show you first the OSPF configuration. We need to run OSPF from MultiPod drivers to spines. So show run, show LLDP neighbor, show run interface, heat 149.4. One of the requirements for MultiPod OSPF configuration, we have to use a sub interface, which is .1Q vlan 4 header. That's one of the requirements. So in this case, we have an interface Ethernet 149, which is connected to one of the spines. In my case, is George 101 is one of the spines, and here I'm using the encapsulation .1Q4, and NTU has to be a 50 bytes bigger than 1500 bytes. So for the VXLAN header, so in case we increase it to 9150, and I put this IPN in a VRF in case you guys using IPN. Some most customers, they use their core as the IPN routers, and so we have separated this from the other traffic so we don't mix other traffics with IPN. So, and then we also have costed the OSPF. So we want to make sure because for the multicast to work correctly, we don't want to go to reach, let's say, from Cougar to get to the RP, which is the baboon, the primary RP. We don't want him to go through the spines. So that's one of the reasons, because it's going to fail. So that's one of the reasons we have costed any of the interfaces going to the spine higher than normal, which is 1 by default. Go back to my screen. So, and then OSPF network is a point-to-point, and we have enabled PIM on all the IPN routers. So then let me show just to verify, show IP OSPF neighbor, VRF IPN. By the way, we are using 93.180 on these 4 boxes, EX. So as you see, we have a neighbor with the spine and the neighbor with our IPN routers. So let me show you our multicast configuration. Show run VRF IPN. As you can see, we have 2. This is part of the best practices. So you want to configure these 2 groups as a BIDR, 225.00/8 and 239. So that covers all the multicast that's required for the IPN for the each side to talk to each other. So, and in our case, the rendezvous point IP is 11.222, and in a multicast BIDR, we use concept of phantom RP, which it doesn't really exist anywhere. It's just let me show you how the configuration is done. Show run NFS LO100. So we have, as you see, the address on the loopback is 11.221/30. And if I go to Cougar, which is the router next on the other side, Cougar is on this side. And if I do show run, here's the secondary. As you see, he's a /29. But our rendezvous point is a 11.2.2.2, as you see in our config. So from his point of view, if I go to show IP route for 11.2.2.2, this is a phantom RP, VRF IPN. As you see, he knows how to get to this through Ethernet 151. Neighbor, which is baboon. So if I go to baboon and run the same command, since we don't have any interface for that 11.222, but it's part of that subnet /30, as you see, baboon, you see that he said to get to this network, go to the loopback. So that's why they call it phantom RP. The actual 11.222 doesn't exist, but it's part of that subnet. So, and now, so in order to, let's say, all the bomb traffic that is from each part, bomb traffic means broadcast, multicast, and unknown unicast. We're going to carry that across, let's say if I'm ARPing for a device from pod 1 to pod 2, and the leaf doesn't know anything about it, he's going to proxy spine, and if spine doesn't know, we're going to send that bomb ARP request through multicast BIDR across to other side. And when they respond back, then we know the actual device, and then we don't have to, get bump traffic across. So if I go to my ACI and look at one of my tenants that we're going to extend VLAN 100 across MultiPod. So here is my network 100. Is L3 configuration. Is subnetwork 192.168.100.1. And if I go to advanced troubleshooting, as you see, this is a multicast address he's using. So let's look at this multicast address. So from the spine point of view, if I send a join, because these guys, the spines, from the multicast point of view, they act as a igmp host. So let's say if there's a request, they join that group. So for that group, one of the spines is going to join that group. So in a multicast, we're not going to be doing both. Are not going to sending join, because then you can create a loop. So one of the spine becomes a designated router for that particular group. So they load balance between. So how many BD you have? So some spines are acting as a primary, the other one acts as secondary. So let's say if in our case, if I go back to my routers, if I do show IP, mroute, VRF, IPN. So this is a multicast group for BD 100. As you can see, in a multicast spider, there is no concept of source group. Everything is star comma G. So that means everything has to go to the RP. So in our case, in a multicast, we also do 2 RPF checks. RPF stands for reverse path forwarding check. So we want to make sure the routing and RPF matches. If they don't match, then it fails the RPF. So in our case, incoming interface, always check for where is the rendezvous point. So from his point of view, he knows rendezvous point connected to the loopback, which is correct. And then if you notice in a Ethernet 149.4, this is a connection to the spine, and he's sending that join. And then we also, EAT150, is sending that join to this group. So if I do show CDP neighbor, EAT150, which is Coyote. If you look at the diagram, Coyote send the join. So it sounds like to me, from the spine on this side, send the join, Llama, and then from his point of view, he could go this way or this way, and Llama send it to the Coyote, and Coyote to that one, the primary RP. So if I go back to Coyote, so now if you notice here, incoming interface toward the rendezvous point, which is EAT150, shows CDP neighbor, EAT150 toward Baboon, and the RPF neighbor is 11.1.1.1. If I do show run interface EAT150, which is correct, other side is that one. And then he's also, if you notice there is no more join is coming from this spine, because he's also connected to the spine. Show LLDP neighbor. So they see right here 102. So he's not sending the join. So in this diagram, so George is the guy sending the join for this group. And if I go back to my router here, so now also the join is coming back. Is also coming from Tim right here. One is the Llama 151. Tim join. So if I go to Llama, as you see, he's doing RPF check toward the rendezvous point, which is 11113, Ethernet 151 shows CDP neighbor, which is Coyote. 111130. This one. This side is 29, the other side 30, and also if you notice the join, it's coming from the spine. And if I go to this router, Cougar, you shouldn't see any join from here, because spine 201 is a designated router for this multicast group. So.
All right, so that gives us a pretty good idea of what you're looking for, because obviously if that RPF neighbor is incorrect, that's going to cause a problem, right?
Exactly, and then you got to make sure, as we discussed, cast these interfaces toward the spine much higher. So this way we don't get into this scenario that from IPN router they think they need to get to the rendezvous point through the spine.
Right.
Which is going to fail.
And the main reason we're doing that, folks, is for the multi-pod architecture, all of the bum traffic, we're not doing head-end replication on the spine line cards or the spine devices. So the bum traffic is isolated to those multicast groups and being routed by the PIM biter in the IP, and that's why there's a PIM biter requirement on the devices that support the IPN. So if we send multicast traffic through the spine in a multi-pod architecture, that multicast traffic is going to be dropped as it tries to get to the RP. So that's the reason, as Javed was talking about, we're inflating those costs. Let's see here, Javed, do you mind getting into Baboon and doing a show run interface towards the spine? We'll talk through the different configurations, which you've already highlighted, I think. So as Javed already mentioned, we already talked about inflating the OSPF cost on the spines. That's the best practice. That's going to keep us out of problems. MTU, the devices have to support. Jumbo MTU 9150 is the most common MTU you're going to see on IPN devices. The encapsulation .1Q of 4. The spines, the reason why people are like, why 4? Why do I have to use 4? Can't I use 5 or 6 or 7? No, it's 4 because the spines, you've got to think in pod 2, before we configure the spines, before we have the ability to configure the spines, there's got to be an already existing configuration that's kind of waiting for the DHCP request to allow the DHCP request to go from pod 2 over to our Apex and pod 1, and that is having the interfaces, they understand that if they see a .1Q tag of 4, that is a special header that's going to be allowed for IPN connectivity. So we've hard-coded the .1Q header of 4 into our spine interfaces. They understand what that means. They understand it's multipod. So that's why it has to be this .1Q header of 4, because that's frankly what they're expecting. If you don't, so on the DHCP relay, where do we have that configured, Javed?
Let me show you. So here, you have to turn on the feature, which is a DHCP.
Right.
So here's service DHCP and also featured DHCP. Let me see, there is it. Featured DHCP.
Okay.
And then service DHCP and IP DHCP relay. These are the 3 commands.
Okay.
And then also,
go ahead.
So from let's say our pod 1 is already fully configured and we're bringing up pod 2. So, and pod 2 initially, they have no IP address. They need spines, they need to get their IP address and then leads. So we need to set up the helper on the interfaces, toward the spine. So send the DHCP request to the APIC and the pod 1. So what we need to do is we go to Llama and show run interface it 149 10.4. So in my case here, I have I'm pointing to my two APICs, 10.0.0.1 and 10.0.0.2. So by default, when you create a TEP pool, let's say for pod 1, let's say in our case, the TEP was 10.0.0/16. So the first IP is going to be on APIC 1, and the second would be APIC 2, and the third would be APIC 3. So it's always going to be like that. So I already knew my 10.0.0.1 is going to be my APIC 1. So you configure that on your facing toward the spine from the IPN point of view. And then also if you do show IP route 10.0.0.0 IPN, as you see, we're seeing /32 for the APICs. It's coming in via, so here is my APIC sitting down here. My APIC this is my APIC 1. He's advertising his network from the leaf point of view via ISIS to the spine, and the spine is going to redistribute that into OSPF, which goes to the IPN router. So, and this is my second right now. As you see, we're seeing IPs of the spine, APICs through IPN. And as you see that, you see OSPF type 2, which is external routes.
Right. Okay.
So the main thing is, the main thing you have to watch out for IPN. I see a lot of usually issues is usually the multicast issue with the binder, or configuration with the DHCP relay, things like that. So, but the main thing you want to make sure when you're configuring multicast, you need to make sure at the end type in the binder for that group.
Okay.
So.
Very good. So we've covered basically all of the configuration must-haves on the IPN. What about inside of the fabric? I mean, I've heard of an issue where that requires us to change the ISIS metric, for example. Can you walk us through where that is and what that's doing?
So in case we lose a spine and the spine coming back online, by default the metric on ISIS is set to 64, and we cannot go worse than that. So you could black hole the traffic. So what we need to do is change that behavior. So we poison the route for 10 minutes to make sure the spine is coming online and is ready to start sending traffic through it. So let me show you the configuration for that. If I go to fabric policies.
There you go.
Profiles. And click on this book right here. And you see it says resolve IS policy. You click on that. By default, this is set to 64. And you cannot,
so you cannot
go. Exactly. This is one of the things you might want to change that before you go in production. To 32.
Okay.
And let's see, anything else as far as multipod here? Right now I'm sending traffic, by the way. I'm extending layer 2, VLAN 100 between the two sites. And as you see, we are sending 10,000 frames per second from Mammoth 31 to Mammoth 33. Both sides are receiving the traffic. So here's on my diagram. Mammoth 31 is in the pod 1. Mammoth 33 is the pod 2.
I think that's it. Anything else, Luis or Javed, from MultiPod? Anything else you guys can think to add at this point?
Just let me see if I go to the fabric here also. I can show you something else also on the inventory tab. As you see, we have configured 2 pods, and then fabric setup. So you see we have two different tab pools for we're using 10.00/16 for pod 1 and 10.1.00/16. And one other thing, if you go to tenants, from infra tenant point of view, that's where all the magic is happening from the GUI. So if I go to under L3 out, and pretty much here's so this is we use the GUI to set up the multipod, and I can show you that.
There's like a workflow, right? That you can take through to go through to do that, yep.
Yeah, so, and it's very easy, but some customers, they use Postman but the GUI has been enhanced in this version, so it's much easier to set up the pod, So what you do is pretty much, if you go to Fabric Setup Policy on the Quick Start right here, and add a pod. So when you're selecting your pod, and we want to add a pod here, let's say. And as you see, it's getting started. Now he's asking you the pod. You give it your pod 1. Let's say tab pool. Pod tab pool is here is our. You select your tab pool. And then now here you're going through the spine, So in our case it's 101. And then you can add the second spine, and you give it the IP address. Let's say, I just want to show you how easy it is to set it up.
So this is the interface that would be going towards the IPN, correct?
That's correct. Yeah. And then next. So it depends how many. If you have more than one, you can add all your spines and click on plus here.
Okay.
And you add this, so it's easy. Next. And then you select interface policy. You're using OSPF point-to-point, and it's right here. You see that point-to-point, advertise subnet. You can have an option to enable BFD, or ignore the MTU. So,
okay.
Next. And here is our. So for the external tab, you need to generate a tab for the outside the fabric. So in my case, I've created 192.168.1/24 for pod 1 and 192.162.0/24 for pod 2. So you see data plane tab. This is our unicast tab. So anything we send between pods, this is our, this IP.
And that's shared for the entire pod, right?
Exactly. So the two spines, or how many spines you have, they're going to share this IP address.
Okay.
And this is our, and then it's asking here for our external for pod 1. So you give it the IP address again. That's the router ID. Loop back. So you say next. And you see right here is all, this is done for you. You don't have to create access policies. You don't have to create any L3 out. You don't have to do any, AEP. It's all done for you. You don't have to create a pool, none of that stuff. So it's all scripted for you.
And one of the things that this is doing is, remember that not one queue header of 4 we were talking about, right? So the AEP, the VLAN pool that it's referring to here, the spine interface policies, the spine switch profiles and policies that you're used to creating on leaves. It's doing it for the spine so that when that interface we selected is connected to our IPN, it's going to have an AEP that allows it to a VLAN of 4. So it's going to associate that VLAN of 4 with that interface. So
that's correct.
All right.
So once you finish this, then you add the second part, and that's all you have to do. And if IPN configuration is done correctly, the spines. From the pod 2, they're going to get their IP address, and they're going to see the other side, and it's going to start showing up in a fabric membership. Then you can join them to the fabric.
Very cool.
All right. This concludes the IPN configuration.
Awesome. Java, Luis, thank you so much.
Thanks for watching the video today. If you'd like more ACI how-tos, design guides, and best practices, check us out on the web at unofficialaciguide.com or on YouTube.